Ernesto, acción.
Hello, I'm Pablo Escobar, and today we're graphing functions. Please come in.
Okay, so this is the graph that we have over here. We already have our function and we have 3 points in the graph. What we're going to do is we're going to move this line and up 3 points above. First up, we need to look at our function, x minus 4. That tells us that we need to first equalize to 0 so we can know to which side of the graph we're going to move it. Cami says that it's x equals 4. So we're going to move the points 4 points to the right because it's positive. And so we start graphing. Once we are done having the points, we're gonna cross a line through it. But we're not done yet. Besides the square root, we have a plus 1. This means that our point is going to move 1 point up because it's positive as well. You think we're done yet? Well, we're not. We need to look at one last thing in our function. We have a minus sign before we start the square root. This means that we're going to make a reflection, but not just any kind of reflection. We're going to reflect or mirror our line above or down. How are we going to do this? Cami, can you help us, please?
So this is our initial line, and
And that's how you reflect your function. And this is going to be the last answer you're gonna get, the right answer. Don't forget to get the domain and the range.
Okay, now we're gonna get a little further with the procedure. Now we're gonna see the absolute value function, transformation and reflection. So, what does this mean? Okay, right here we're gonna start with number 2, okay? So, what does this mean? That this should move 2 up, 2 points up. And then this, what's next? Now that we move these 2 points up, we're gonna do x equals 0. So x minus 3 equals 0, so x equals 3. What does this mean? That we're gonna move the graph 3 points to the right because it became positive actually. So 1, 2, 3, and up. So right here we're gonna put our center point. So if you move right here and right here and right here, and now we reflect. Yes. So we're gonna make our center point right here. No, sorry. Right here and right here. So we have the reflection, and finally we got the answer. But don't forget. Hello again. This has been made for slowness issues. So we are gonna start with this function. We're gonna factor it, okay? And then what we should do, cancel the x's plus 3. So what's next? By getting the HA, we're gonna use this formula. AXN divided by BXN. So if the powers are equal, it automatically becomes the numbers. So here they are the same power, so it would be 2 over 1, which means it will be 2. So the HA is 2. So now the VA, this easily will be by. Can you give me a small reminder, please, my friend?
You choose the x minus 3,
Yes.
and you equal it to 0.
Yes, you equal it to 0. What we did in the past video. So x will be 3, which means that here, this line would be the VA, and this line would be the HA. So what's next? All right. The whole. I don't personally remember what is a hole, but Manfred can explain.
A hole is a point in the graph where there's no graphing, where the line just goes through. And we get this hole by first off with the function that you cancel, like the
So
factor
these
one.
ones?
Yes, you're going to equalize to 0, which will give you -3.
-3, alright?
And then this -3 is gonna go inside the x of the function that you have, and it's gonna give you 0.5, and you graph it, and no line can go through.
Alright. So, well, what will we next? The y-intercept, for example. To get the y-intercept, you need to get equal the x's to 0. So it will be 0, 0, this cancels, this cancels totally, so it will be as simply as this, -1. So you have the right, where do we have it? Where do we have it? Right here. I will just write it down. The y-intercept will be this -1. This is the y-intercept. So to get the x-intercept, we got get the y equal to 0 to the f of x. So if we do the graph, all these, you know, it will get us -1.5. So that will be the x-intercept. Now, the domain and range, first we need to graph. So, once we have the, how do I say?
All these things,
All this, yeah.
you graph,
Yeah. I'm sorry, I missed a little. You graph it.
and then in the other side,
And then in
by
the other
doing
side.
this.
That was missing. So you gotta replace the number of x you would like to right here. Yes? And that will give you the y. But it gotta be in these spaces because that's the graph. So in here we chose 2, which will give us -7 in y. We chose 4, that will give us 11 in y, and -1, which will give us -2.5.
And that's how
that's
we
the
graph.
That's the graph.
And then
actually.
you-
Then finally the domain and range, right? So the domain, you simply go right here.
And
Where
then
does it go? In -3. Yeah, I mean in 3. So it will be
Function. Here we have 9, joining x squared plus -9. But we need to do first, we need to factor, and we're going to see that we have two things that we can't cancel. So that means we're gonna have 2 vertical asymptotes, which are going to be -3 and 3. We're gonna grab them over here. Once that's done, you obviously need to get that HA. But as you see, the HA is gonna give a 0, so it goes in the line. Meaning that there's no x-intercept because no points can go in that x line. Once this is done, we're gonna go and do the x and the y. We're gonna get the points that we need, which are going to be 4, 5, -4, and 5. And we're gonna grab the points and we're gonna make them. And we do have a y-intercept. The y-intercept is a -1. We're going to graph the lines, giving us 3 different graphs. Last but not least, we need to get the domain and the range, which we forgot to mention in the last video, but it's also very necessary. The domain and range is going to be really easy. We're going to go walking. We're going to stop by the -3, so it's from -infinite to -3, union from 3 to, from -3 to 3, union from 3 to infinity. That's going to be our domain. And our range, we're going to go walking, and we're going to stop at -1. It's going to be -infinite to -1, and union -1 to 0. It's going to be our range. That's it.